Okay, so welcome everyone. I am Kailash Prasad, a PhD scholar from Nano DC Lab IIT Gandhinagar. Welcome to live session 6. We have this session every Tuesday, and all the sessions are actually recorded. This you can find over my YouTube channel. And the main goal of this session, again, right, is to understand the basic concepts via questions, right? Yeah, I will share the YouTube link. So the main goal is to understand the digital circuit design via solving various questions. And these questions, whatever I will be discussing over here, will help you to to design your assignment questions. Also, it will help you to crack some of these competitive exams like GATE, ISRO, ESC, right, all over like that. Most of the questions which are discussed over here are from these competitive exams, previous year NPTEL questions are like that. Okay, so if you guys have any doubts, any problems over here, you can ask me. Okay, so I will start with the session. This is the course layout, and in the last week what we have discussed some of the questions on sequential circuit. This session is also a follow-up of sequential circuit only, and we'll be discussing a lot of questions today. If you don't understand anything, please let me know. We will start with a very basic question, and I call it as question 0. And the question here says that what is the mode of this asynchronous counter? Okay, so there is a counter which has been shown over here, and what is the mode of this asynchronous counter? So j plus k is not there; it is j equal to k, right? So j and k is 1, right? So it is in toggle mode. And now the question has been asked: what will be the mode? Anybody wants to answer? Mode means after what number the pattern will start repeating. That is what we call as mode, right? Anyone? You can see over here that the clear of each of this signal, right, has been connected with one logic, right? So this is the clear signal, right? So mode means when it will start again from 0000, right? So assume that initially it is 000 and it has started counting, right? So if you see, it is an asynchronous counter, right? So if it is like 00000, right, then it will be 00001, right, and it will just keep on doing that. Okay, Mala is saying that the answer is 28, right? We will see what will be the answer, right? And it will just keep on doing that unless and until this clear signal gets activated. Now the question is, when this clear signal will get activated, right? And you see here that this is an active low signal. So what I want, that I want the output of this NAND gate, the output of this NAND gate 0. My question is, when does the output of NAND gate is 0? I have three inputs. When does the output of NAND gate is 0? Anybody want to answer this? Anyone?
When all the inputs are 1.
Yeah. So that's the correct answer. So what I want is, I want all these inputs, right? So 1, 1, 1, right? It means these three should be 1, right? So the thing is, your MSB, when so you see, right? This is the MSB, right? So how I want to represent my number? I want to represent like this, okay? Q4, then Q3, then Q2, Q1, and Q0. Okay, so it will be like this: Q3, sorry, Q4, Q3, Q2, Q1, and Q0. When all these three are 1, right? And as soon as this 3 becomes 1, it will remain 0, right? It will remain 0. As soon as this 3 becomes 1, my clear signal will become 0, right? In all other cases, the clear signal will remain at 1, and your counter will be resetted to again 000. So that's the thing. Now you see what is this number, right? So this is 16 plus 8, 24 plus 4, 28, right? So this is 28. Okay, so it means after 28th cycle, the counter will reset itself to 0, and it will just keep on counting from 0 to 28, 0 to 28, 0 to 28. So the mode of this asynchronous counter is 28. Everybody understood this question? Everyone? Other students? Everybody please reply such that I should know that okay, you guys are understanding. Okay, so that's the goal, right? If you just come here and just go without understanding, then there is no point of having this kind of session. Okay, so now let us start the second question. Okay, so this question one, right? What is the output signal frequency for following circuit with 5 megahertz clock signal? Okay, so this is 5 megahertz. Okay, now there are four options, right? So output means Q. Okay, what is the frequency of Q? The option is the output will be 5 megahertz when t equal to 1, right? 10 megahertz when t equal to 0, 10 megahertz when t equal to 1, and 2.5 megahertz when t equal to 1. Okay, so we have four options over here. Anybody wants to answer? What will be the answer here? The question is what will be the frequency of Q at what t? Matlab, the question is at what t value the frequency of Q will be what? So let me solve you for this question. Okay. So let us first consider t equal to 1 because three options are t equal to 1. Then we will consider t equal to 0. Okay. So if I put t equal to 1 here, right? Please note that this is an XOR gate, right? So for an XOR gate, A, B, this is Y. Okay. 0, 0, 0, 1, 1, 0, and 1, 1, right? So this is the truth table of XOR gate. So everybody know. Now you assume that initially it is 0. Okay. Initially it is 0. What will happen in the first clock cycle? Initially, initially your Q is 0, right? And in the first clock cycle, right? Clock. Let me name it clock cycle 1. What will happen? So if this is 0, right? And this is 1, right? And this 0 will come here. It means 1 0. The output of this XOR gate is 1, right? In the first clock cycle, the Q will become 1, right? The Q will become 1, right? So here the output will be 1. Then you go to next clock cycle, right? T is 1. Okay, so 1 and 1, so this will remain 0. Okay, so in next clock cycle what will happen? In the next clock cycle, the Q is 1 earlier, right? The Q will become 0. Okay, then in the third clock cycle, T remains 1. Okay, the T in the third clock cycle. So if this is 1, again it will become 1, right? So it will happen like this in every clock cycle. In every clock cycle, what will happen? The node will start flipping. Okay, in every clock cycle. It means, see, this is my clock. This is my clock. It's like that. Okay, this is my clock. Now, what is happening in the first clock cycle? The Q remains 1. It's like that. Okay. In the next clock cycle, Q becomes 0. Right. In the next clock cycle, Q remains 1. Right. And in the next clock cycle, Q becomes 0. So, what happened to the frequency? Anybody want to comment on that? What is the frequency of this and what is the frequency of this? This is 5 megahertz, I know. Right. What is the frequency of this? Vivek is saying 2.5
2,
megahertz.
2.5.
Right. Everybody agrees with that. Right. So, I have only one option, 2.5 megahertz. Right. So, this is correct. So, it is nothing. This circuit is behaving like a frequency divider, right, which divides your frequency by 2. Okay. Everybody understood? The answer is D. Everybody understood? What about other students? Okay, I hope everybody understood. Let's move to next question. Very simple question. I have a 5-bit counter. I have a 5-bit counter, right? And what will be the modulus value of a 5-bit counter? That's the question. What will be the modulus value of the 5-bit counter? It's a 5-bit ring counter. Please note that. 32. Okay. What about other students?
Sir, 5?
5. Okay. I have two options. One option is 32 and one is 5. And please note that 32 is not there. So obviously 32 won't be here. What about other students? It's a 5-bit ring counter. Please note that that's very crucial, right? So I understand 32 would have been correct if it was only a counter, but it's a ring counter. Okay, so ring counter, how does it work? It will remain 0001, right? And it will be 0010, then 00100, right? 0100, then 1000, right? And then again 000001, right? It will be like that. So after 5 cycle, it will start repeating. Uh, Ibrahim, it is not 50, rather it will be 5. Okay. So why I'm saying like that, ring counter works like this, right? So the one will be keep on shifting. One will keep on shifting, and then you will repeat the pattern. Okay. So the answer is 5 over here. If it is a ring counter, the answer is 5, right? Why? Because it is moving like a ring. Okay. Just assume that uh, the logical diagram of a ring counter looks like this. Okay, something like this. And okay, it won't be like this actually. So something I have a counter, right? If I have a 5-bit counter, I should have 5-bit flop. And the thing is, the queue is actually connected over here. It's like that. So initially, so it's a shift register like a kind of thing, right? It is just shifting the value. Also, it is a counter. So initially, it will remain at 00001. Then it will be 000 0, right? And then it will just keep on happening, and the final answer will be, sorry, the final state will be 1000, and again 000001 will repeat. So this is the question number second. Now moving to question number third. Yeah, it's a bit complex, but yeah, not too complex for you guys. What the question says here that the content of following register Q4, Q3, Q2, Q1, Q0 after 2 clock transition. Please note that after 2 clock transition are, so, and they have said that initial value of the all flip flop is logic 1. It means that this is 1, this is 1, this is 1, this is 1, and this is 1. Okay, so let me draw this for you. Q4, Q3, Q2, Q1, Q0. Okay, so this is all the values are 1. Okay, now if you see here, there is something that the Q0 is a function of Q1 and Q4. Okay, so if I write an equation for Q0, so Q0 is Q1 XOR, so Q1 XOR Q4, right? So this is another function. Okay, now they are asking that, okay, after two clock cycle, what will happen, or what will be the answer? That's the question. Anybody wants to answer this? Anyone? You can comment on your answer in your chat box, such that, okay, no answers. So let me solve this for you. Okay, so in the very first clock cycle, what will happen, right? So see, it will move from Q0 to Q1, Q2, Q3, Q4, right? It's like that. So the Q0, sorry, yeah, the Q0, this Q0, okay, it is an XOR of Q1 and Q4. And please note that Q1 and Q4. Okay, this question is difficult. Okay, let's see if it is difficult or not, right? So Q0 is Q1 XOR Q4. Okay, so please note that Q1 is 1, Q4 is 1 initially, right? So if you put an XOR of 1 and 1, what will be Q0? Q0 is 0.
0.
Okay, in the very first clock cycle 1, if I say clock cycle 1, and for all other values, what will happen? It will just shift, right? This one will be shifted over here, this one will be shifted over here, this one will be shifted over here, and this one will be shifted over here. It means it will be 1 1 1 1, and the q0 has changed, right? uh, okay, let's see now. The second cycle, in the clock 2, right, again the very first thing what I will do. So let us put the initial state for second cycle. What is the current state? It is 0 1 1 1 1, right? So in the next state, what will happen? The q0 will be 1 coming from here. Okay, again 1 coming from here. 1 XOR 1 is 0, right? 1 XOR 1 is 0. So in the next clock cycle, it will again remain 0, right? Please note that this 0 will be shifted here. It means q1 is 0, right? This one will be shifted here. It means q2 is 1. This one will be shifted over here, the previous state of 1, right? The q3 is 1, and this one is shifted over here. Q4 is 1, right? So this is the two cycle, right? Only two cycle it has been asked. It means the answer is 1 1 1 0 0. So 1 1 1 0 0. Is it correct, everybody? Do you think if it is correct?
Yes, sir.
It is correct. I do not have this in my option.
Yes, sir. But I'm also getting the same answer.
You are also getting the same answer.
Triple one double zero.
Okay. Yeah. So after two cycle, the answer will be actually 1 1 1 double 0. Right. So this is the correct answer. I think I have missed. So the answer, the question has been asked was for actually 3 clock cycle. Okay.
If it is three, we can say that B is the answer.
Yeah, if it is 3, then B will be answer, and let's see. Okay. So instead of, so after 2 clock cycle, if it means that in the third clock cycle, what will happen? Let's see. Right. So this is the first clock transition, the second clock transition, right? And if I also have a third clock transition in the clock 3, right? Let us see what will happen. So if it is so what is the state? 0 0 1 1 1, right? So in this state, before the clock cycle, the result will be 1 XOR 0, so this will be 1, right? And as soon as the clock will come, this q0 will go to here, so it will be 1, right? This 0 will go to here, it will be 0. This 0 will go to here, it will be 0, right? This 1 will come over here, it will be 1, and this one will be come over here, it will be 1, right? So the answer will be 111, sorry, 11001. That's how it is. Okay. So after third clock, in the third clock cycle, the answer will remain 1. If it has been asked for 2 clock cycle, the answer will be 11100. So see, the question was not difficult, right? So the question is, you just have to approach in a very simplified manner. The thing is, okay, for all the q's, q1, q2, q3, q4, if I write the equation, q1 is equal to q0, right? q2 is equal to q1, q3 equal to q2, and q4 is equal to q3, right? This is the equation. Only the equation of q0 is q1 XOR q4. So in every cycle you can calculate, right? What will be the answer? If you follow this equation, you will get the answer in the next cycle. Is that clear, everybody? Everyone? How to think logically? Okay, so this is the logical thinking only, right? So see, the very simple way to approach any problem, if you have this kind of problem, you write the equation of everything. Okay, q1, q2, q3, if they have asked, you just write it down, and once you write it down, right, it will be extremely simplified. Okay, you just have seen, okay, it is q1 XOR q4. So initially, if you initialize 1 1 1 1 1, in the next cycle, what will be the answer? So q4 is, so if this is q0, q1, q2, q3, and q4, right? Q4 is q3, so I have to put this value to q4, so this is 1. right? Q2, Q3 is Q2, so this will come over here, right? Similarly, this will come over here, this will come over here. So this was for the first four value. For the fifth value, Q0, it is Q1 XOR Q4. It means you have to take an XOR gate, right? So everybody knows that if both the input of XOR gate are same, the answer will be 0, so it will be 1110. And similarly, in the next cycle, you just keep one value, you will get the final answer. Okay. So moving to next question, question number 4. The minimum number of flip-flop required to design a mod 150 counter is. It's a very simple question. I need an answer quickly. How many flip-flops will be required to design a mod 150 counter? Anyone?
7.
7. Okay, I have one answer on 7. What about other people? 8. Everybody is saying 8. Everybody is saying 8. So two answers on 8. What about other people? Everybody is also saying 8. Bangla is saying 8. Okay,
Yeah,
majority
that is
is saying 8.
8.
Okay.
Yeah. Wrong.
Madhuvan, okay, everybody is 8. Okay. So, yeah, so the answer is 8 actually. Okay, and how the answer will come? Please note that if you want to design a 2-bit counter, right, you require 2 flops. If you want to, sorry, the thing is, if you want to design an n-bit counter, right, how many flops will be required? It will be log 2 of n. Okay, log 2 of n. It is not n bit mod n counter. If you have mod n counter, log 2 of n will be required. Okay, so pardon me for my mistake. So if you want to design mod n counter, log n state will be required, and this will be the number of bits also. The number of bits will be also log 2n, right? So if you see 150, right, so this is greater than 2 to the power 7, right, less than 2 to the power 8, so you have to take the upper value, so you require 8 bit, right? You have to round it off. So the minimum number of flip-flops required for a mode 150 counter, 8 bit. The minimum number of flip-flop required for an 8-bit counter, what will the answer for an 8-bit counter? Please note that I am asking 8-bit counter, not mode 8 counter. Anybody want to?
8.
8, right?
8.
Whatever is the number of bit, that's the same number of flip-flops will be required. Okay. So yeah, moving to next question, question number 5. Okay. So anybody wants to attempt this question? Which of the following output sequence produced by the following circuit? You just have to answer that. Okay, what will be the output sequence that will be followed by this circuit? What will be the output sequence? I have 4 output sequences provided over here, right? One of the important thing that has been given over here, that all the flops are negative edge triggered. Okay, all the flops are negative edge triggered. Anybody wants to answer this? Option A. Okay, Ibrahim is saying option A. What about other students? So let me start quickly. Okay, so I can have two initial states, right? Either 0, 0, 0, 0 or 1, 1, 1, 1, right? So let me start with 0, 0, 0, 0. So if my initial state is 0, 0, 0, 0, okay, so let me write it down. Q2, Q1, Q0. So it is 0, 0, 0, 0. Okay. So what will be my next state? In the falling edge of the clock cycle, in the falling edge, I have to see what will happen. Okay. So please note that this is a T flip flop, right? So if the input of T is 1, right, at every falling edge, what will happen? The output will be toggled to 0. Okay. Our output will be toggled to from 0 to 1, 1 to 0. It will happen like that. Okay. So if it is initially 0, right, so that is fine, right? Now assume that clock 1 falling is coming. Okay, so clock 1 falling is there. So a falling edge has come. So what will happen? This 0 will become 1, right? This 0 will become 1. It means if this 0 has become 1, what kind of transition has happened at this node? What kind of transition? Anybody? Is it a rising edge or a falling edge?
Rising.
Rising edge, right? So it means the node or the value of this T flip flop will remain at 0. It won't change, right? And again, there is no transition over here, so it won't change. So what will the output? It will be 1, 0, 0. It will be like this. Okay, Madhubalan is also saying 001. Oh, sorry, A. Okay. Now let's see if the next falling edge has come over here. Okay. So what will happen? This one will go to 0. Now 1 has become 0. It means it's a falling edge, right? It's a falling edge. So if it is a falling edge, this T flip flop will be activated. Okay. This one will 0 will go to 1. And for this node, this is a rising edge. So it means this flip flop will not activate in the second clock cycle, right? If clock one falling edge has come again, so what will happen? This will become 0. So Q0 is 0. It has changed. The Q1 has become from 0 to 1, right? And Q2 remains at 0. Okay. Now moving to the third clock cycle. In the third clock cycle, what will happen? Third falling edge, right? This 0 will become 1 again, right? So it's a positive edge over here. Okay. This 0 has become 1. And it is a rising edge, right? 0 has become 1. So it won't change. If it won't change, so it is also not changing. It means it will become 1, right? So this is remain at 1 and this is 0, right? Clock falling. So the sequence is 000, 001, 010, 011, right? So the answer is the first one. Everybody is clear on this? How I have attempted this question? Everybody? What about other students other than Ibrahim? Okay, Vivek is saying repeat. What about other students? Okay, so let me repeat once again. Okay, I think yeah. So I have to do it again for you guys. Okay. Yeah, I will start from again. So let me assume that initial state is 000. Okay, and all of these nodes will switch only if there is a negative edge. Okay, so let me write like this. Okay, so so if this is my 0, right? This is 0 and this is 0. It's like that. Okay, so sorry, this is 0, this is 1, 2. So what I will do, I will write Q2. No, I will write like this. Okay, clock 2, clock 1, clock 0. Okay, so for I have named the clock of these three different T flip flop, and then I have Q2, Q1, Q0. Okay, if I write like this. Now what we have to do is we have to see what will be the sequencing. Okay, so initially assume that uh, the clock is there is no falling edge which has come initially, and initially this is 000. Okay, now what will happen initially if all of these are 1, because why I am saying all of these are 1, I can start with 0 also, but that is fine, right? Because this will only get activated if there is a falling transition. Okay, so that is the reason why I have kept initially uh, this one, but this will remain 0, right? This will remain 0. This is clear, right? I think I have drawn it wrong. Let me do it like that. This will 0, right? And let me keep it 0 only initially, right? It is like that. Okay, so what will happen initially? It will 0 0, it will go to 1, right? As soon as rising, this is a rising transition which has come over here in this node, in this node, right? There won't be any change, right? There won't be any change because this won't be activated. This will be only activated if there is a falling transition. So Q node will remain at 0, so no problem, right? So I have two cycles, but nothing happened. Now let's see, this node will go from 1 to 0 again, right, in the next clock. Now as soon as this node goes from 1 to 0, 1 to 0, what will happen? This node will flip because it is a T flip. Because it is a T flip, whenever there is a edge triggering, this node will flip. And what will happen if this node has flipped? This Q0 will become 1. Okay. And what will happen to clock 1? This is my clock 1, right? So clock 1 has become 1, right? Because Q0 has become 1, it means clock 1 has become 1, right? Clock 1 has become 1. And what about clock 2? Because it has only become 1, what has happened here? It is a rising transition, not a falling one, right? So that is the reason why this node will not change. So Q1 won't change. Why? Because in the clock 1 there is a rising transition. So if this is not changing, so this node will remain at
Sir, please, sir, please explain about the transition, sir.
transition.
Yes, sir. What is transition?
Okay. The transition means if your value is going from 0 to 1, right? It is a rising transition. If your
Okay.
value is going from 1 to 0, it is a falling transition.
Okay, sir.
Right? So everybody
Okay.
understand. So whenever I'm saying that okay, it is going from 0 to 1 over here, if it is 0 to 1, right, it is a rising transition. Okay. If it is going from 1 to 0, it is a falling transition. Okay. So transition means that. So coming back to the question, what has happened? Clock 2 is 0 and Q1 has not changed, Q2 has not changed, right? Because there was only falling transition in this node. Okay. Now coming to next cycle. Next cycle means it will again go to 1, right? So if it again goes to 1, so there is a positive edge over here. So here in this node, it is going from 0 to 1. So nothing will happen, right? It will only happen in the falling edge, right? So I will just write as it is. I will just write as it is, okay? Whatever is the state. Now again, if it goes to 0, so if it goes to 0, it means there is a falling transition here, right? If you see, there is a falling transition here. It is going from 1 to 0. So what will happen if it goes from 1 to 0? This value, you see, this value was 1, right? Initially it was 1. It will flip to 0. If it is flipping to 0, the Q0 has become 0. What it will do? Yeah, Q0 will toggle. So what it will do, as soon as Q0 changes, this clock, right? What has I named here? I have named it is clock 0. This is clock 1 and this is clock 2, right? So the clock 0 has changed from 1 to 0, right? Because Q and clock 2 has is actually equal, right? And as soon as this goes from 1 to 0, this goes from 1 to 0, what will happen? Q1 will toggle, right? So this will become 1. So Q1 has become 1, right? And if you see here, if Q1 has become 1, right, the clock 2 here will become 1. But what will happen to Q2 node? There won't be anything. Why? Because it is a rising transition. It means it is going from 0 to 1. See, the things will only happen if it is going from 1 to 0, right? Why it has happened here 1, right? Because it was going from 1 to 0, right? So this node will remain at 0 as it is. The Q2 will remain at 0 as it is, right? Coming to quickly to next step, it will be 1, right? So if it is 1 here, if it is 1 here, right, nothing will happen because it's a positive transition, so it will remain at the same state. Everything will remain at the same state, right? Again going to a falling transition. So if it falls again from it goes from 1 to 0 again. So what will happen? This node was 0, right? So it will toggle to 1. So this will toggle to 1. Now, as soon as this toggles to 1, this is the same node is connected to clock 1. The clock 1 will go 1. And after that, what happened? This is a rising transition in this node. So this node won't change. Q1 will not toggle, Vivek. Why? Because this node has gone from 0 to 1. Okay. Did you understand? This node has gone from 0 to 1. Q1 will only toggle if node is going from 1 to 0. Okay. So nothing has happened. So the Q1 will remain as it is. And this will also remain as it is. Okay, so this node is 0, like that. And after that, I think we already have the pattern, right? So it started from 0 0 0, then 0 0 1, then 0 1 0, then 0 0 1 1. Everybody understood what I have done over here? Everyone? Yeah, Vivek has understood. What about other students? Okay, yeah. So this was, yeah, one question which was little tricky, but yeah, if you follow the steps, you will be able to answer this kind of question. Okay. Moving to the next question is again a similar kind of question. Okay, for you, I'm throwing out lot of questions like this such that you should understand. What is the output QA, QB, QC, QD? Please note that they have asked QA, QB, QC, QD. Okay, so the sequence should matter. Of the following circuit after 5 clock transition. After 5 clock transition, assume initial output state of all the flip flops are logic 0. So initially everything is 0 0 0, right? So QA is 0, QB, QC, and QD. Okay, so initially it is 0 0 0. Then I have the first clock. Okay, anybody wants to answer what will happen? Ibrahim is saying that he thinks that the answer will be A. What about other students? Quickly do it for you. So see, this node, again, this node is connected to Q bar. Okay, so it means 1 is here. Okay, so as this node will go to 1, what will happen? As this node will go to 1, right? So this node will flip from 0 to 1. Okay, so it will be, anybody wants to answer what will happen? So this node, as soon as this goes to 1 in the next clock cycle, right, this node becomes 1. So QA becomes 1, right? The other nodes will remain at 0 0 0, right? Now in the next clock cycle, see, in the next clock cycle, what will happen? This is 1, right? So this node is initially 0, so Q bar will still again remains 1, right? So if that is the case, this 1 will go to 0, right? So this 1 will go to 0. Initially it was 1, so this will flip, right? Once this will flip, this node will become 1, right? So this node will become 1 and it will be 0 0 0, right? Then again what will happen? It will just keep on happening, right? It will keep on happening because for the T flip-flop, if the state is 0, the output remains 0. If T flip-flop, the input is 1, it will toggle, right? So this you should note. Okay, so it will become 1. Then as this node becomes 1, it was 0, right? So if that was 0, so this will remain 1. Okay, so let me just follow this through. Okay, every time what I will do, I will just erase for you and I will just make sure. Okay, Madhubalan is asking that will it be 0 0 0? Let us see. Let us see. Okay, so if this is 0 1 0 0, right? So please note that this will 1. This will be 1. Okay. Now what will happen? See, if this is 1, this node will become what? This node will become 1. This is 0. Nothing will change in this node. So this will remain at 1. Right? This is 1. So this node will change. Right? So this node will become 1. Right? And this is 0, so this is 0. Okay, after that I will again erase and I will again just set up the value for you. So this is 1 1 1 0, right? So this is again 1, please note. Okay, so if this is 1, this 1 will go to 0, right? So this will go to 0. If this was 1 earlier, this will again go to 0, right? If this was 1 earlier, this will again go to 0, right? And this was 1 earlier, so this will go to from 0 to 1, right? From 0 to 1. Okay, so the state is 0 0 0 1. Okay, so I will write it like this: 0 0 0 1, right? So this node is 0. Okay, so if the input is 0 for a T flip-flop, will the output change? No, right? The output won't change. So what will happen? The output will remain at 0 0 0 1, right? So because for this input is 0, for this input is 0, for this also 0, for this also 0. So whatever the output it has given, it will just remain as it is. So the answer is 0 0 0 1 rather than 0 0 0. Everybody agrees with me? Okay. Thank you, Ibrahim. What about other students?
Yes, sir.
Okay, so now you guys have understood this, so we'll move to next question. We have a lot of question today, okay? So and I will try to cover everything. So you please wait. So this is the state diagram of this. There is some circuit, and there are four state diagrams, and you have to tell me that which of this state diagram is correct. Anybody wants to help me with this? I will help you like this, okay? And you have to tell me that whether which of the state diagram is correct. See, there is an input A, so A, right? And I will write a pseudocode for you, okay? I will write a pseudocode for you, and you option C, okay? Ibrahim is saying option C. Uh, let's see what is the option, right? So I will write a pseudocode. It means if A is equal to 0, right? If A is equal to 0, right? What happens if you see this node?
Y is equal to x,
Y is equal to
x naught.
q1, right? Yeah, it's everything, right? So it's the same thing. And if A is equal to 1, right? Y is equal to q, right? This is a very simple code, but the thing is here there are two dependencies. Okay, what is the previous dependency, and we will see, right? So we have to see that initial state, if it is 0, right? What will happen if my input is coming, right? So if my A is coming, what will happen to my Y? We have to see that. Okay, so let us assume that if q is 0 initially, if this is 0 initially, okay, so you assume that q equal to 0 is this state, q equal to 1 is this state, okay? You can assume like that. If q is 0, right? And if your A, whatever the input that has been provided, what I will do, I will try to make a state diagram, and we will see, okay, what will happen. Okay, so if q is 0 and this is q equal to 1 state, okay, there are two states for q. If this can be 0 and this can be 1, okay, it can be like that. Okay, so if q is 0, okay, and what I have done, I have provided, if q is 0 and I have provided A is equal to 0, right? If q is 0 and I have provided A is equal to 0, A is equal to 0 I have provided, what will happen? What will happen to q? That is my question. Okay,
1. The q becomes 1.
q becomes 1, right? Why q will become
Yeah.
1? Because this was 0, this was 1, right? So if A is 0, this node will be selected and this will go over here. It will be like that, right? So it will try to make q equal to 1. So it means whenever q is equal to 0 and A is coming 1, oh sorry, A is coming 0, if A is 0, right, the q will become 1. Okay, I hope this is clear to you guys. Okay, this is q is equal to 0 and this is q equal to 1. Okay, now I have the second option. If my q is equal to 0 and A is equal to 1, okay, if my q equal to 0 and a is equal to 1, what will happen in that case? Anybody? Madhubalan is saying D, but my question is, if my a is equal to 1 and q is equal to 0, what will happen?
The same will remains because the Q is the input.
Right, so q is the input, because if a is 1, this input will be selected and this is q only, right? So it won't change. So this will be like this. Okay, if my a is 1, if my a is 1, right, it will remain as it is. That's how it is. So for this node it has been done. Let's go over here, right? If q is equal to 1, what will happen? Okay, so we will see it again, and we will try to answer it, right? If q is 1, okay, and my a is equal to 0, so what will happen in this case? Students, please answer. It's simple, right? If a is 0, this will be selected.
The X naught will be selected, so 0 will be answered.
Y is equal to 0, right? So it will go to q equal to 0 state. Means if a is 0, it is changing the state, and if a is 1, right, the q will be selected and it will remain as it is, right? So if a is 1, right, it will remain in q equal to 1. Okay, which of the option it is saying? This graph, whatever I have made, not a very good looking graph, but yeah, which of the option is correct, students?
Yeah, these.
It's D, right? It is D. Did you guys understood how I have approached the problem? Yeah, Kiran, it's D. But the question is, did you guys understood how I have done? Okay. Student, this was the first question on state machine today. Yeah. Okay. Once again, Sufal is saying, what about other students? I will repeat. Don't worry. Okay. So, because if you understand this only, I will move ahead. We have follow-up questions on state machine. Okay. So you should understand, okay, how the state machine has been made. So what I will do, I will just quickly do it for you. Okay. You see, it is a multiplexer. So if a is equal to 0, okay, y equal to q. If a is equal to 1, right, y equal to q bar. Okay, so I have this state machine has been designed for q, right? So I have two states. One is q equal to, either q is equal to 0 and the other is other state is q is equal to 1. Okay, the other state is equal to q equal to 1. Now what will be the next state, I have to find out on the basis of a. Okay, if my a is something, what will be my next state? Okay, so if my a is equal to 0 and q equal to 0, right? If my a is equal to 0 and q equal to 0, I think I have written it incorrectly, right? So if a is 0, it will be q bar, and if a is equal to 1, it is q. It's like that. Okay, so now the question is, if my a is equal to 0, what will happen? The q node will flip, right? It will be q bar. So you can directly quickly write, if a is equal to 0, right, q node will flip, it is going to next state. If a is equal to 1, it will remain as it is. Okay, if a is equal to 1, it will remain as it is. So a is equal to 1, q will remain as it is. Similarly, for q equal to 1, again follow the same thing. Okay, again, if a is equal to 0, y equal to q bar, it means q was 1, q will go to 0. So a equal to 0, it will be like this. And if a is equal to 1, if a is equal to 1, right, y will be q. So wherever you are, you will remain as it is. It is like that. So if I write the equation like this, it will be very simple for you. Is it clear, everybody? Is it clear? Okay. Yeah. So moving to next question. Again, one of the questions. So there is a finite state machine that has been drawn over here. Okay, so you consider this as an FSM, and the question is, it has been designed using D flip flop A and B. So I have two D flip flops A and B, and I have couple of logic gates. I have an NAND gate and I have an XOR gate. Okay, so let us first understand. Okay, what are the things we have? We have two D flip-flops, one XOR gate, one NAND gate. Okay, now what it is saying that assume that x is equal to 1. Okay, so this node is 1 every time. It is fixed to 1. So okay, that is also fine throughout the operation of the FSM. So that's the thing. When the FSM is initialized to QA equal to QB equal to 0. So what is the initial condition? So first you have to see for any FSM or sequential logic, what is the initial condition? And the initial condition over here is 0, 0, right? And it is clocked after 2 cycles. What will the output? That is the question. So initially it is 0, 0. Okay, QA is 0, QB is equal to 0, right? And after 2 cycle, what will be the output? Okay, so in the clock 1, we have to see. But you see, we have provided the initial condition for this node. This is 0. So what will be the initial condition for this node? Everybody, anybody? It is a NAND gate. What will be this node? This one.
That is one.
Okay. What about this node?
That is XL 0.
That will be 0, right? So we have the initial condition, right? We have the initial condition. Now what we will do? We will clock it. Okay. In the first clock cycle, this 0 will come over here, right? So QA remains at 0. Okay, this one will go over here, right? So QB will be 1. Done. Okay, Madhubalan is saying that it will be 1, 1. So in the clock 1 I have 0, 1, right? What I will do, I will just erase and I will make it again. This is my 0, this is my 1, right? This remains at 1, right? So this will be again, it is the same condition, right? So it will be 1 only. What about this node? Anybody? What will happen to this node in the clock 1? It is 1. Okay, so because it is an XOR of 0 and 1, so it is 1. Now moving to clock 2, as soon as the clock 2 comes, I have the initial condition, right? So this one will go over here, so the clock QA becomes 1, right? This one will go over here, right? So this is also 1, right? So this is my clock 2 and the answer is 1, 1. Okay, so whoever has said B, the answer is 1, 1. Is that clear, everybody? Is that clear? What about other students? Is it clear? Other students? Okay. Yeah. I request students just to type yes or no, right? So such that I should understand. Okay, you are getting. So, which of the following statement is true? 1 minute question. Anybody wants to comment on it? Output of the milli-circuit depends on current input only. Output of the milli-circuit depends on current input, current state of the circuit. More machine output depends on current input only. None of the above. Which of the statement is correct? Anyone?
I think B.
Okay. So B is the correct option actually. Okay, so see in the millisircuit, in the output depends on current input and current state. Okay, for Moore it depends on current state, right? So that's the reason only B is the option which is correct. So quickly moving to next question. So very simple question it is, but what you have to say is this is a state machine for you. Okay, the sequence is 111. After this sequence and the initial state is there, so you have to start from here, right? What will be your state after this sequence and what will be your output? Okay, what will be your state and what will be your output? Anybody wants to answer this? Archana is saying C. What about other students?
C and 0.
C and 0. Okay, so you are also saying the C option, right?
Yes, sir.
So let me see if you guys are correct or not. Okay, so I don't know the answer, so I am trying to solve the answer. Okay, so if this is a, so if the initial state is a, the first sequence is 1, right? So let me see. Okay, if the sequence is 1, right, the output will 0 and I will go to B. So I'm here at B. Now I have another sequence that is 1, right? So where I am now, I am at B. And if my next sequence is 1, right, I will go to C. Okay, so I am at C now in the second when the input is 1, right? And if the third input is 1, right, so I will check. So if it was 0, I will go to D, but it is not the case. If it is 1, I will remain here. Okay, so the output is 0, right, and the state is C. So the output is 0, the logic is 0, and the state is C. Everybody is clear on that? uh, okay, any student, anybody has doubt in this part? Feel free to ask, don't worry. Okay, I'm here to repeat for you, assuming that everybody understood. So I think probably it is the last question for the day. So I have 5 JK flip-flops. Okay, and these are cascaded. You see the JK of 00, it is connected to clock over here. This node is connected to clock over here. This node is connected to clock over here. This node is connected to clock over here. Right. So it is an asynchronous counter kind of thing, right? So you know that this circuit, you know, but you know from front to back. Now it is showing you back to front, right? It is showing like that. Now the question is, clock pulses at a frequency of 1 megahertz are applied. Okay, so this clock that has been applied is at 1 megahertz, 1 megahertz, and it is asking the frequency in kilohertz for the waveform Q3. Q3 is this. Okay, so what will be the answer? 125k. Somebody is saying 125k. Archana is saying 62.5k. 125k and 62.5k. Anybody else? Okay, so let me see what is the answer. Okay, so please note that clock will be applied here, and J and K is 1. Okay, so I will write it down. Okay, Q3, Q2, Q1, Q0, and Q4 also. Okay, so you see that as soon as this will, so initially everything remains at 0. Okay, so as soon as the clock will be applied, what will happen? This will become 1. Okay, this will become 1, right? Everything will remain at 0, right? In the next clock cycle, this will become 0, right? This 1 will come here, right? And what this will do, this will make this 1. Okay, so this will be 1 and this will be 0, and this will keep on happening until this value becomes 1 1 1 1. It's a counter. Okay, this value becomes 1 1 1 1, right? So what will happen, that if you see the Q3, Q2, Q1, Q0, and Q4, initially it was 0 0 0 0, right? And it will just keep on happening like this, 0 0 0 1, right? It will just keep on happening like this. And at the seventh clock cycle, it will be 0 1 1 1, right? And then it will become 1 0 0 0. Okay, please note that this remains at 0. Okay, and after 15th clock cycle, that is actually the 16th one, because it started with 0, right? What will happen? This will become all ones. At the 15th, it will become all 1, and this will remain 0, right? And after that, this becomes 1, and everything remains at 0. Okay, if you see Q3, so Q3 has remained 0 for 8 clock cycles, and for next 8 clock cycles it has remained 1, right? So when it has completed one complete clock cycle, or one complete cycle, right, in 16, when it has changed 16 cycles, right, it has completed one. Okay, everybody agrees? Do you have any doubt? Right, so if you see, this is 16, right, at the 16th level, right, this has completed one cycle, right. Now the question has been asked that, okay, what will be the frequency, right? So the frequency has been provided as 1 megahertz, right? So what will be the frequency over here? So the frequency of the clock, right, will be divided by 2 for this, will be divided by 4 for this, divided by 8 for this one, and divided by 16 for this one. Okay, so 1 megahertz will be divided by 16, and the answer will be 62.5 kilohertz. Everybody agrees to that? Yeah, Janki, it will be 62.5 kilohertz. Everybody agrees. It's a simply clock divider, right? The at one clock cycle, this will divide by 2, this will divide by 4, this will divide by 8, and this will divide by 16. Right? So the frequency of Q3 will be 1 megahertz divided by 16. And if I would have asked Q4, what would have been the answer? Anybody? Frequency of Q4? F by 32. Can you give me the number?
31.25.
1.25. Okay. So let me just tell you, the frequency of this node is 31.25. This node is 62.5. This node is 125, right? This node is 250. Everything is K, okay? Kilohertz. Everything is kilohertz, okay? And this node is 500 kilohertz. It is like that. Everybody, did you get this part? Everyone? Please respond. Okay. So that's all for today. Okay. So if you guys have any question, feel free to ask right now. I think I had one question from somebody. Are you still there at the starting? Okay, I think that guy is not there. Yeah. So, okay, explain about state diagram. What do you want, Vivek? Can you speak? What do you want? What kind of explanation you want? FMS. Okay, FSM you are saying. Finite state machine. So do you guys want a session or tutorial on finite state machine? Is it like that? I can prepare a session and I can solve many questions just on FSM. Is that fine? I will start with million more FSM and I can discuss that. Do you guys want? That is my question. Vivek is saying, what about other students? So what I will do, Vivek, in the next session, I will just create a million more machine tutorial for you guys. And okay, last problem. Yeah, I will be discussing the last problem once again. So I will create a tutorial on FSM and then I will discuss with you how to solve and how to design FSM. Okay, this has been discussed in class also, and I will try to solve some of the questions so that you better understand what is the concepts behind the FSM and how to tackle the questions of FSM. Okay, so last question is very simple. Let me just give you like this. So So if you see here, okay, so this is the clock cycle, and this node is 1 and 1. And what will happen whenever the clock will come, this node will go from 1 to 0. Okay, and at 2 clock cycle, this node will go from 0 to 1. Then so first it will go from first it will be 0, then in the next clock cycle it will become 1. Okay, so when it becomes 0 to 1, it means there is one clock cycle of this node. Okay, so I have written like that only: q4, q3, q2, q1 and q0, right? So initially it will be 0, then all will be 0, right? Because everything is 0 and 0, right? And then what will happen? It will become 1, right? And everything remains 0, right? And when after that, uh, if it becomes from 1 to 0, right? So this will become 0, and this node will become 1, and this will remain 0, right? And similarly it will just keep on happening. You just connect and you will see that what will happen after some time, it will become 1 1 1, and this will be 0. Okay, so this will happen, and after again some cycle, because it has from 0 become so it will be like this, and after some cycle it will become 1 1 1 1, right? So this will remain at 0, and after because total 16 cycles have been done, right? uh, it will become 0 0 0 0 again, right? Please note that at every clock cycle we have written down these values, right? At every clock cycle we have written down this value, and we see that q3 has completed one clock cycle. One clock cycle means what, right? A 0 transition and a 1 transition, right? And again becoming a 0. So this is one transition. So for completing one transition for q3, how many times this clock has been moved? So how many times whatever we have written, it was on every clock cycle, right? So it has been the clock cycle was 16. So after 16 clock cycle you get again this 0 value. It means after 16 clock cycle, q3 has completed one cycle. So if the frequency of clock is 1 megahertz, then what will happen to the frequency of q3? It will be 1 megahertz divided by 16, right? If you divide 1 mega into 16, so this will be 1000 by 16 kilohertz, right? This will be 62.5 kilohertz. So this what I was explaining. Did you get the answer? Did you get it? Who has asked? Ushashri, Alu Ushashri. Did you get it? What I've explained? Okay. So yeah, that's all for today. We will meet again same time at 6 p.m. I encourage all of you to join this session, right? And if you have other friends you know, right, you should encourage all of them to join this session. All the videos will be available in the YouTube channel, and let's meet again in the next session. With we will discuss about FSM, and we will discuss some more complex question in the next topics. Okay, so please practice these questions, solve the assignments, also solve many questions from GATE and other exams, so that you understand the concepts of the digital electronics. Okay, so thank you everyone for joining. We will meet next session.